Hello dear students, welcome you all for transmission and distribution class. So in the previous class we have seen how to calculate the string efficiency. Now let us see how to improve the string efficiency. So while going increasing the string efficiency, the different methods are there. That is, first one is by using the longer cross arm. So longer cross arms means the cross arms are nothing but it is the supports from where a pole the support is given on the pole where the insulators are fixed. So the value of string efficiencies depends upon the value of K, that is ratio of the shunt capacitance to the mutual capacitance. The lesser the value of K, the greater the value of string efficiency, and more uniform is the voltage distribution. So the value of K can be increased by reducing the shunt capacitance. In order to reduce the shunt capacitance, the distance of the conductor from the tower must be increased. So the longer cross arm should be used here. It can increase the distances. So obviously decrease the value in K. So the string efficiency increases. Next, by grading the insulators. So grading the insulator is one of different method. Here insulators of different dimensions are chosen. Means till now we have seen all the insulators are of same category, but in this grading method different insulators are used for different categories, so that the uniformity in the voltage distribution can be achieved. So this gives the good results by going with this method. So the insulators are capacitance graded. They are assembled in the string in such a way that the top unit has the minimum capacitance. Increasingly, at the bottom unit means the unit which is near to the conductor, which is having the maximum capacitance. Since voltage inversely proportional to the capacitance, in this method it will tend the equalization of the potential distribution across the string. By this we can improve the string efficiency. And another method is by using a Gauge ring. Using the Gauge ring is a different method where the potential across the each unit in a string can be equalized by using a Gauge ring, which is a metal ring electrically connected to the conductor and the surrounding the bottom insulator. You can see this figure 8.13. One metallic ring is used from the bottom of the conductor to the insulators. Okay, so this Gauge ring introduces the capacitance between the metal fitting and the conductor. The Gauge ring is controlled in such a way that shunt capacitance currents I1, I2, etc. Are equal to the metal fitting, which is there I1 dash, I2 dash. So the same current I flows through the each of the string, so it will equalize the current which is flowing in the shunt capacitance. So these are the three different methods are used to improve the string efficiency. Next, coming to the some important points, the maximum voltage appears across the disc nearest to the conductor, that we should know. The voltage across the string is equal to the phase voltage, that is voltage across the string is equal to voltage between the line and earth, which is nothing but phase voltage, and line voltage is given by root 3 into voltage across the string. See, we will see the one problem here of example 8.1. In a 33 kV overhead line, there are 3 units in the string of insulator. If the capacitance between the each insulator pin and earth is 11%, and the self capacitance of 11% of self capacitance of each insulator, find the distribution of voltage over 3 insulators and string efficiency. So we can see in this figure 8.14, 3 capacitors are there because of 3 insulators. So all the same, no grading of insulators, so all the capacitors of value is C and shunt capacitance is Kc. They are given 11%, no, so we can give that K is equal to shunt capacitance by self capacitance, which is equal to 0.11 because it is given in 11%. Voltage across the string is taken in phase because 33 kV is line voltage divided by root 3, which gives you the 1905 kilowatt. At junction A, we know that applying KCL, I2 is equal to I1 plus I1. Same equations you are seeing in the string efficiency equations. V2 omega c. So we know that V2 is equal to 1.11 V1 by putting the value of k. Okay, actually we are knowing the equation that V2 is equal to V1 into 1 plus k, where k is 0.11. You put that value, you will get V2 is equal to 1.11 V1. At junction B, once again you apply the KCL. You are knowing equation V3 is equal to V2 plus V1 plus V2k. Put the value of k and V2, you replace it by V1's value in terms of V1. So you will get V3 is equal to 1.34 to V1. What is total V then? Total V is equal to V1 plus V2 plus V3. So togetherly you add all the three voltages, you will get 3.45 to V1. So which is nothing but V, 19.05 kilovolt. You are already calculated first. So you can solve for the V1. You will get V1 as 5.52 kV, V2 as the 6.13 kV, and V3 as the 7.4 kV. As you calculated, it is very clear that the lowest insulator which is near to the conductor has got the maximum voltage distribution, that is 7.4 kV. To find the string efficiency, what is the equation? Voltage across the string divided by number of insulators into V3. So total voltage is 19.05 kilovolt divided by 3 into lowest insulator is having 7.4, which gives the 85.8% of the string efficiency. One more problem we'll see here. See, in this problem, a three-phase transmission line is being supported by the 3 disc insulators. The potential across the top unit, that is near to the tower, E and the middle unit are 8 kV and 11 kV respectively. They are directly given the values of V1 and V2. So calculate the ratio of capacitance between the pin and earth to the self capacitance of each unit. And second one, the line voltage and the string efficiency. You need to calculate. Here the values of V1 and V2 is already given. So the same figure which is you are seeing here, the same figure you can assume with the V1 and V2 values are known. Okay. So we know that shunt capacitance value is Kc. At the junction A, I2 is equal to I1 plus I1, V2 is equal to V1 plus 1k. So anyhow V2 you are knowing, V1 you are knowing. You can calculate the value of k by solving the equation. You will get 0.375 as the k. So applying the same KCL at the junction B, you will get the equation for V3. Just put the values of V1, V2 and V3 in terms of V1. Anyhow the V3 is given by V2 plus V1 plus V2 into k. No, already you are knowing V2 and V1 values. You will directly get the value of V3 as 18.12 kV. Once you know the V3, you can add V1 plus V2 plus V3. Togetherly you will get 37.12 kV as the V. So to find the line voltage, you multiply it by root 3. And string efficiency, you can use the same formula. You will get 68.28% of the string efficiency. Yes, one more problem is there, 8.3. You can once again go through this problem, first two problems, and solve by your own, and try to solve the 8.3 problem as well as 8.4 and 8.5 problems. So by this major parts of your first module is finished. Any doubts you can ask me, and you refer the books which I have sent you. The same notes you can apply. Okay, thank you.